we're using just the plain product rule. And the product rule states that if I have the same index, so I have an index of what in here? If it's not listed, what is it? It's a 2, right. So I have an index of 2 here, an index of 2 here, which means that I have the same index. I can multiply whatever's underneath the radical, and that's called the radicand. So now I'm multiplying 5 times 13. What's 5 times 13? Yeah, they're 2s. 65. Yep, good, 65. So really that just means I'm taking the square root of 65. And for right now, I'm just leaving it like that. Okay, number 2, I have the same index in both cases, so I'm multiplying what's underneath. When you multiply 15 times xy, it's literally just 15xy. So I have the square root of 15xy. Number 3, same deal, multiply what's underneath the radical, so 3 times 17. 51, good. Now, number 4, we don't have the same index. One's a 2, one's a 3. So because of that, for right now, we can't simplify that. Next class, we're going to do a little bit of it, but for right now, it cannot be simplified. That one takes a little bit more work, so we're going to hold off on that one for now. Number 5, we have the same index, so what would be my answer? Cubed root of 14, good. Number 6, what's on? Perfect, cannot be simplified. Now 7, don't let that one trip you up. We have the same index, so I can multiply what's underneath, which means I'm just multiplying everything.
Even if they're not in the same order?
Yep. So we have the 5th root of, what's 9 times 8? 72. What'd you say, Alicia? Well, x to the what power? Second power, good job. And then y to the 4th, perfect. Remember when that, for those of you confused on that one, when you multiply two variables together, you have to add the exponents. So that's how we got x to the 2nd and y to the 4th. And number 8. Same index. I can multiply them. So I have the cubed root of what? For x to the what? Good. Y to the good. So really, your summary, if the radicals have the same what? Index, good. So that's what you're filling in the blank. So if the radicals have the same index, and I'm going to add a little bit more to that. So if you have the same index and you're multiplying, so you have to be careful because maybe it doesn't work for every operation. And you are multiplying. Multiply the radicands. So the stuff that's underneath the radical. If they don't have the same index, they can't be simplified. So in the next section, we're doing the quotient rule. So before we were multiplying, it was product. Second section is quotient rule, so I am dividing. And it works the same way as the last section that we were doing for most of them. So we have number 1, we have the square root of 25 over 36. From previous classes, what do you know that answer is? What's the square root of 25? 5. What's the square root of 36? 6. So your answer is 5/6. That just means that I'm taking the square root of the top number and the square root of the bottom number. Now number 2 is a little bit different. Do we know what the square root of 13 is? No, so I'm just writing square root of 13. And then what's the square root of 49? 7. Be careful, number 3 is not a square root, it's a cube root. So the cube root of 18, we don't know that one. Well, not yet, anyway. And the square or cube root of 125? Good job. Okay, 4, we're taking the 4th root. Now, for the top one, I'm actually going to have you rewrite that with a fractional or a rational exponent. This would become y to the what if I'm rewriting it with a fraction instead of the radical? Would you say, Jericho? It will be, but before then I want to show that next step, 8 over 4. But you're right, it'll be y squared. And then the 4th root of 16, 2. So Jericho was right, 8 divided by 4 is 2, so we have y squared over 2. Okay, number 5. The negative is on the outside, so what does that mean? When do I apply it? After, good. So negative goes on the outside. And then I can't simplify the cubed root of x squared, so I'm just going to write it as the cubed root of x squared. But in the denominator, I can simplify that one, so I'm writing that as y to the 12 over 3. And what's 12 divided by 3? 4, right. So I'll have negative cubed root of x squared in the top as my numerator. And in the denominator, I have y to the 4th. And the last one. 5th root of x, because I can't do anything else with that one. And what's the 5th root of negative 32? It's negative something. What did you say, Joey? Oh, I thought you said something. Oh, you said 2? Good job.
I was right.
Yeah. So we have the 5th root of x over negative 2. So the first thing you want to write down in your summary is the fact that your variables, what we did with the variables was convert them to rational exponents to y. The variables should be converted to rational exponents. To simplify. And we want to make sure that we're treating the numerator and denominatorly. Now we get to do the fun stuff on the back. And that's going to be like our Go Fish that we played. Okay, cool. All right, so on the back, we're simplifying these roots, and you don't want to use a calculator for them. So that means I'm not getting a decimal approximation. I'm actually simplifying the radicals so that it's easier for me to see. So 32, I'm actually going to create factor trees for all of these. So 32, I need to come up with 2 numbers to multiply to give me 32. I don't care which numbers they are, what 2 numbers multiply to give me 32. Really? What times what is 32? 16 and what? 2. You could have done 8 and 4. That works fine too, so whatever one you want to do. It's going to get you the same answer in the end. Okay? From there, I need to split up 16. So how can I split up 16? 4 and 4. Now, we need to look at the index. So what is the index for number 1? 2. So that means that when I play Go Fish, I'm looking for groups of 2. So look at the final 3. We have 2, 4, and 4. And I'm looking for groups of 2. So I see 2 4s, so I'm going to circle those. And that's going to be my pair that I sit down. But I only, like, when we put down a pair of 2, we only write it as one stack, right? It was only one stack on your table. So that's why I'm going to write it once. So 4. And then what's left over in your hand? The 2. So that means I still have a 2 left over, so I need to keep radical 2 right there next to it. So this 2 is left in my hand. So my answer to simplify the square root of 32, I can write it as 4 root 2, and it's the same exact answer. We're doing the same process for all of these. You just need to figure out what the index is and split them up so that it works. So 300, what are 2 numbers to multiply to give me 300? Okay. I would do 150 and 2, but 150 would be a little harder to break down. 103. Does that work? All of the ones that you stated will work. It's just some of them take a lot longer to simplify than others. So 100 I can split up into what 2 things? 25 and 4, which would work. But there's another one that's a little bit better. 50 and 2 would also work. There's also another one. 10 and 10. Now, the reason why those aren't as great is because I would have to split them up further to come up with all of my pairs. Whereas this, I already see that I have 2 pairs right away, so it makes it easier. All of those things will work. You would just have to write out all of the factors a lot further. We'd need a lot longer of a paper in order to do that. So I have 2 10s. My index was 2 up here. So I know that I can write it out as one book. That's what they're called, a book. So I have a book of 10, and then what's still left over in my hand? 3, exactly. So I'm taking the square root of 3, stays in my hand underneath the radical. Okay, number 3, how can I rewrite 35? 7 and 5. Can I break those down any further? No. So this one cannot be simplified. The difference between number 4 and numbers 1 and 2 is the fact that now I have a variable and I'll have to deal with that one a little bit. So in number 4, I can write 16 as what 2 things? 4 and 4. So I know I'll have a book of 4 on the side. That's my one set. But then I'm going to write out m cubed. So m cubed, I'm actually going to have 3 little lines because I can write m cubed as what 3 things? Right, m and m and m. And my index is 2, so that means I'm looking for groups of 2. So I have a set here, which means I can write that as one book all by itself. But what's left over in my hand? An M, exactly. So left over. So that will go underneath my radical as just one M. Now 54, that's a little bit different. We have an index of 3 this time. So let's start off doing the same thing. I'm looking for, let's look for 2 things that multiply to give me 54. 9 and 6. Okay, we'll do that. Now let's split up 9 and 6. So 9 can be split up as what 2 things? 3 and 3. And 6 can be split up like 3 and 2. Now my index is 3. So I'm looking for groups of 3.
Can you group them up, like, even though it's from 2 different numbers?
Yes. So all of the last steps, as soon as you've broken them down as far as they go, you can group any of those things.
Oh, so any, like, as you break them down?
Yep.
Okay.
That's why I said, like, for the square root of 300, you could split it up any way you want. You're just going to have to go back through and circle all of those numbers, whereas we split it up into 103, and 100 can be split up into 10 and 10. So it makes it easier.
So you have 3?
Yep, we have 3 3s. So that one's going to go on the outside, because that's a book. We're looking for a group of 3. And then what's left over? The 2. So that's left over. And when I put that underneath my radical, it's the cubed root of 2 because my index was 3. So cubed root of 2. Okay, 6 in concept. We're working with an index of 4 this time. I'm going to move this down. So I have 243. How can we split that up? I thought I heard something.
It's like 8 or something.
The easiest one, and I'll just give this one to you for now, is 3 and 81. Because then I can split 81 up into 9 and 9. And from there, I can split it up into all 3s. So I kind of just skipped a step because I don't have that much space, but you could definitely split it up into 9 and 9, and then 9 and 9 split up into 3 and 3, and 3 and 3. So I have an index of 4, looking for groups of 4. So we have 1, 2, 3, 4, and then we have one lonely 3 left over. So I can write that as my book of 3, because I had a group of 4. I'm taking the 4th root, so that has to stay where it is. And then my lonely 3 gets left underneath the radical. Number 7, we're back to an index of 2. So that thing you always have to make sure of. Right, I'm going to split 25 up into 5 and 5. Good. And let's write out p to the 7th. So p to the 7th would equal p times p times p, so on and so forth. And I have an index of 2, so I'm looking for groups of 2. So 1, 2, 5s, so that on the outside. Here's one group of p's. Second group of p's, so that's one group, that's 2 groups, that's 3 groups. So I have p cubed, because there were 3 of them, 3 groups of that. And then 1 lonely p left over. So I have the square root of p, and that's my final answer. Now, for some of you, it's going to get really tedious to write all of the p's out. So if you're able to and you would like to, there's a shortcut. And that just means take your 2, which is your index, and put it into 7. So 2 goes into 7 how many times? That's 2 times 7. 3 times. So 3 times 2 is 6, and I have 1 left over. So you could have done 3 p's and then 1 left over. This is just using long division, the assumption that there will be remainders. But like I said, if you're visual and you need to write out all of those, that's fine. It's whatever works best for you. Keep in mind, though, if you have 50 billion p's, you probably don't want to write out 50 billion. I mean, that's just my assumption. That would take you forever. Okay, number 8. Getting more variables in here. So we still have an index of 2. So 72, what are 2 things to multiply to give me 72? Okay, 9 and 8, that works. 9 can be split up as what 2 things? 3 and 3. And it can be written as 4 and 2. And then 4 can be written as 2 and 2. So I kind of ran out of a little bit of space. I'm looking for sets of 2 because I have an index of 2. So I have 2 3s, and here's 2 2s. So when I start writing my answer out, I'm going to have a 3, but then I also have a 2, so they need to be multiplied together. And then there's 1 lonely 2 left over. Leave just a little bit of space in here because we have to think about the variables. We might have something that's left over. So 2 goes under here. Now I'll write out the y's. So I have y times y times y. And I'm looking for groups of 2 like before. So we have 1 group of y's. That's going to come out. We have 1 lonely y left over. That goes underneath the radical. And then we have 1 x, and I'm not even going to write that down anywhere because we don't have more than 1. So I'm putting x right underneath the radical with the y. Now you can simplify it one step further just because what's 3 times 2? 6. So I can have 6y square root of 2yx or xy, whichever order you want to put it in. And that would be your final answer. Now if we split up 72 into 2 times 36, 36 can be split up into 6 and 6, and that's how we would have gotten that right away. But I wanted, since Brandon gave me those 2 answers, 9 and 8, I wanted to show you how it would work either way. Now 9 and 10, I definitely want you to star. These 2 things you'll see on a quiz, which, by the way, we have this set of notes, the set of notes on Thursday, and then your first quiz of the 4th marking period is going to be that next Monday. And it has all of the same stuff, so every last question that you had on the open note quiz, and then 3 new ones from this section. So I took out the true and false questions that were at the bottom of the last one and put 3 of these questions. So you have all the materials to study for sections 8.1 and 8.2. It's the same exact stuff, just different numbers. And I gave you back your old quiz. You know which ones you need to work on so you can figure it out for the new one. So on here, this is negative 27. We know the cubed root of a negative is going to be a negative. So I'm actually going to put a negative on the outside right away. And then we have 27. How can I split 27 up? No. 3 and something. 3 and 9. 3 times 8 is 24. So 3 and 9, and then 9 can be split up into 3 and 3. So I have my group of 3 here. So that goes on the outside. Then I have y to the 7th. Again, take the shortcut if you can and are able. I'm looking for groups of 3. One group, 2 groups. I have y squared with 1 y left over. And if you did it the other way, 3 goes into 7 how many times? Twice with 1 left over. So without writing it down, that's how you could have done that one. Then x to the 5th. I have 1, 2, 3, and 2 left over. So I have 1 x out here, but I have 2 x's left over underneath the radical. And then we have 6 x's, or 6 z's. Exactly, z squared. And that goes on the outside. That one will definitely be similar to the one that's on your quiz. And honestly, these numbers, I think, are on your quiz. The only difference is I changed the index. So maybe instead of an index of 3, it's an index of 2. Or maybe instead of number 10 being an index of 4, maybe it's an index of 3 or something like that. That's the only difference between these kinds of questions and the ones that are on your quiz and on your test. So last one, number 10. I'm going to split up 32. The negative's on the outside, so I can keep the negative there right away. So 32. What 2 numbers multiply to give me 32? 8 and 4. Okay. Now, in number 1, we split it up into 2 and 16, so we know what it's going to look like. But I do want to show you how to do it with 8 and 4, since that's what you asked earlier. So 4 can be split up into 2 and 2.